Hi, this is just the beginning of indices. First, we will go through the laws of indices, which we will use in solving different type of questions that are there in the exercise. So, the most easiest kind of thing is a to the power m into a to the power n is equal to a to the power m plus n. This means when the bases are same and they are in multiplication, their exponents are going to be added. I will keep giving an example for every law. Try to understand it. Now, if we have an example 3 to the power 6 into 3 to the power 2. Now look at this multiplication operation. 3 3, both bases are same and there are two different exponents. So 3 to the power 6 plus 2, you are going to get 3 to the power 8. Now if you think that if they are different, then only are we supposed to add? Not at all. You can add when they are same also. So look at the second example. 5 to the power 2 into 5 to the power 2. So here bases are same and they are in multiplication, hence we are adding the exponents. Whether they are same or they are different, it is going to be added. So this is the first law. Now the second law says that the division part will have to say the same law but with division operation. Whenever it is division, the exponent in the division form will get subtracted here. Now you know that the bases are same, both are in division form, their exponents are different. Whether they are different or same, that doesn't matter, but the exponent of the base which is in the denominator is going to get subtracted. Now if at all that happens with these two same examples, what will be the result? Let us see. It is if 3 to the power 6 divided by 3 to the power 2, then it is 3 to the power 6 minus 2, that means 3 to the power 4. Now over here both are equal exponents 2 minus 2. Now here the answer is 5 to the power 0. Now 5 to the power 0 is equal to 1. You will come to know why it is so when I will explain you another rule or law. Once you learn that, you will come to know why anything raised to the power 0 becomes 1. That's why 5 to the power 0 is 1 here. Now let's go to the third law. Now as they were only single base, now we'll take two bases which are like a to the power m into b to the power m. Now you can see that the bases are different but the exponents are same. So at that time what we are going to do is we are supposed to multiply the bases and keep the exponent same. It doesn't mean you are going to add m and m. No, it means what? You are multiplying the base but keeping the exponent as it is. Now the fourth one. Now I need to give you an example. Wait. Now if it is 2 to the power 3 into 3 to the power 3. Now see here, these two are different bases but their exponents are same, hence what you will do, 2 into 3 raised to the power 3, which is nothing but 6 to the power 3. Fourth one, a to the power m divided by b to the power m is going to be a upon b raised to the power m. This is what is going to happen. Now, okay, we could cover 4 of them. More 4 to 5 are there. We'll see what is it. Okay, these all formulas are reversible. Means if the given number is like this, you can split it and write like this. Like if at all 6 to the power 3 is given, I can write it as 2 to the power 3 into 3 to the power 3. Is it mandatory that it should be written only in 2 prime factors? No. As many as prime factors are available as factors of this base, you can write like that. Now this one is also the same case. Now 5 to the power 3 divided by 6 to the power 3, you will get 5 by 6 to the power 3. Now if you have a doubt that ma'am you have got it 5 by 6, it is not divisible, but is it possible that if I have 2 to the power 3 and 6 to the power 3, and if I write 2 by 6 to the power 3, yes, you can reduce and then take the power. That is also correct. I mean to say 2 upon 6 is 1 by 3, 1 by 3 to the power 3. Yes, after making its cube also you will be able to reduce it. Before making a cube also you can reduce it, and then you can get the answer. Okay, now let's move to the next part. Fifth one, a to the power 0 is equal to 1. A is any positive integer. We are not supposed to take this as 0, otherwise you may say 0 to the power 0 is going to be 1 or what. No, it doesn't happen. It never happens. So a here is any positive integer, or a negative integer also you may have it, but anything raised to the power 0 is 1. Here a is never a 0. Okay, so you can take any numbers. I will not be giving examples for this because it is pretty simple to understand. Next we have negative power. Yeah, we'll take up a negative power number. Here it is. If at all I have a to the power minus m is equal to 1 upon a to the power m. This, if at all we just read it, a to the power minus m, what is the denominator? 1. Now to make the exponent positive, we have to take the reciprocal of it. What is the reciprocal of a? 1 by a. Okay, so the exponent becomes positive. Can we write like somewhat what I am saying like this, a to the power m? Yes, you can write, because 1 to the power anything will be 1 only. It will not get affected, and here a to the power m can be written likewise. Now is it applicable to only such numbers, or is it applicable to the fractions? Yes, it is applicable for the fractions also. I'll write this down, you can check it out. A upon b raised to the power minus n is equal to, now we are supposed to take the reciprocal of this to make the exponent positive. That means b by a raised to the power n. This will happen. Now here b is not supposed to be 0. Why? If b becomes 0, the whole fraction becomes undefined. Anything divided by 0 is not defined. That's what is the care that you have to take. Okay, after this we have, hope 7th one it is. Now if you have the two sides like LHS as this and RHS as this, means LHS is a to the power m, RHS is a to the power n. Now on the left hand and right hand side, if the bases are same, then you can equate the exponents. At that point of time, m is equal to n. You have almost done it and learnt about this one. Just to remind you, I have written this one. Here also, a should always be greater than 0 and not equal to 1. Why? Why greater than 0? Again, I would say 0 to power anything doesn't have any meaning. 0 into 0 into 0. You multiply any number of times, 0 will be remaining as 0. And not 1 also. Why? 1 to the power anything is 1. So why need to equate this and that? No point in doing that. So a should not be 0 and a should be always greater than 0 but not equal to 1 also. It should be something other than 1 and 0. Now the next one is the other way round. Means what, ma'am? Now if you have a to the power m equal to b to the power m. Now what do you observe here? The bases are different but the exponents are same. So at that time also we can say, if on either side of the equal to sign, if exponents are equal, we can equate the bases. At this point of time, what will happen? A will be equal to b. Then what are the conditions here when a will become equal to b? Then m is not supposed to be 0. M should not be equal to 0. Then it is valid. Now one more thing comes up as the new one what you have learned this year is p to the power m into q to the power n into r to the power s is equal to p to the power a into q to the power b into r to the power c. Now you can see on either side of the equal to sign, consider p, q, r as different, different numbers, prime factors. Different prime numbers are here and they have particular exponent. Now do you see p and p here on the right hand side also? P, q here on the left, right as well. R in the left, R in the right as well. Now what is differing here? What is differing here is their exponents. Now p is having an exponent as m, p is having an exponent as a, then m is equal to a. Likewise, n is equal to b, and then s is equal to c. Now because their respective exponents we have equated. P on either side, that's why their exponents are equated. Q on either side, that's why their exponents are equated. R on either side, that's why their exponents are equated. This is what you are supposed to follow when more number of factors, prime factors come on either side of the equal to sign. So now I have picked up a few questions from the exercise. You can follow these things. Now first one that I'm going to solve is 10th one, which most of the students have told me that when a number has to be taken as common in the exponent, it is little confusing one. Okay, let's discuss slowly a bit. I know that I'm at very low pace, but you can follow it properly and understand properly. The question says that 5 to the power 2 into bracket n plus 6, okay, into 25 to the power minus 7 plus 2n. Whole divided by 125 to the power 2n. Right. Now you can see that, first of all, understand that whatever the bigger numbers are given, try to make them with the smallest base or the base of a prime 5 is a prime number. So you know that 25 and 125 are the multiples of 5, so bring them in that form. What do I mean? Check here. 5 to the power, first you can multiply this inside because it is 2n plus 12 into 5 to the power 2 is what? 25. Now minus 7 plus 2n. Now here in the denominator also, first I'll write 125 is the 5 power 3 raised to the power 2n. Now what did we use here? We made the base with the prime factor. Now there is no law for writing it, so okay. So what you are supposed to do now, you are supposed to use another law that I will be writing once I use it. Okay, here what is there? 5 to the power 2n plus 2 into 5 to the power. Now here it is m and n. I think I did not mention it. A to the power m raised to the power n will give you a to the power m into n. Means now 2 is in place of m, minus 7 into 2n is in place of n. What are you supposed to do? You're supposed to multiply. Look at the rule or the law. What does it say? So 2 into minus 7 is minus 14. 2 into 2n is 4n. Whole divided by, now here what happens? 5 to the power 6n. Okay. So after this what to do? Now you have the multiplication operation here, and 5, the bases are same, hence we will be able to add the exponents, and 5 being the denominator also, you can subtract the exponent from there. Now check it. I'm erasing both the steps and we'll carry on the next step. Now over here, 5 to the power 2n plus 2 plus minus 14 plus 4n, and this divided by, no, so negative 6n. Now what all I used here? I used 2 rules at a time. Can you use more than one rule at a time? Yes, you can. So what is the rule that I have used? A to the power m into a to the power n is equal to a to the power m plus n, as well as a to the power m divided by a to the power n is equal to a to the power m minus n. Now if you ask, ma'am, can we do this later? Yes, you can, but to save time and step, I have done this. Now you can see 5 to the power, bring all n together, 2n minus 6n. Now this is plus 2. Now I am taking this term out of the bracket. It will not change any sign inside because the sign outside the bracket is positive. So negative 14 plus 4n. Now you can check 5 to the power 6, positive 4, positive 2 becomes 6, and this is negative 6. So 6n minus 6n plus 2, this one we can write plus 2 minus 14 is minus 12. So now what do you get? Oh, 1 second. Here I think we were supposed to take up some number which was, oh, it was x. This is not 2, this is 6. N plus 6 was there, so it will be 2n plus 12. My bad. It will be 12 here. So sorry, not this. I missed it. So here this is 12. So it will be what? Minus 2 only here. Plus 12 minus 14 is 2. And then you are going to get 6 and 6 and cancelled. 5 to the power minus 2. Now 5 to the power minus 2 in the sense, what's that number? 5 to the power minus 2, we are going to reverse it or take a reciprocal of it as 25. Why? A to the power minus m is equal to 1 upon a to the power m. Means what? It should be, okay, I'll write and show, 1 upon 5 to the power 2, which is nothing but 1 upon 25. So this was the question number 10. So hope you have understood this. We'll go ahead with the 11th question. Let me concentrate on what the question is. Okay, the question, okay, here we start. Question 11. The question 11 says that 5 to the power n plus 3 minus 16 into 5 to the power n plus 1 whole divided by 12 into n to the 5 to the power n minus 2 into 5 to the power n plus 1. Now you might see n plus 5 to the power n plus 1 here, 5 to the power n plus 1 here, but they cannot be subtracted because, or cancelled, because here there is one term minus this whole term. Whenever multiplication is there, it doesn't divide the things into two terms, it is only one term. So 5 to the power n plus 1 is in the subtraction with this, so you cannot cancel here. So you are supposed to separate it. Now will we be able to take 5n or more than 5n, 5 to the power n as common? Yes, we can. Now see here, 5 to the power n plus 3 is nothing but 5 to the power n plus 1 I am writing. You may say, ma'am, it is 3, you cannot write 1. Yes, but can I write like this? Why? I can write like this because if I add 2, this will become 3. Why will you add? 5 to the power n plus 1 into 5 to the power 2. Bases are same, so you will be able to add the exponents. That's why I can write n plus 3 as n plus 1 and then 2 minus 16 into 5 to the power n plus 1. Now if you are getting the feeling that ma'am has taken common 5 to the power n plus 1 because it was already here, you are right. Now here also we can do that, but what is it? Is 5 to the power n plus 1 going to come out as a common? No, it will not. Why? Here there is nothing that I can add. The number which is multiplied to 5 to the power n is 12. 12 is not a multiple of 5, so we have to keep it as it is. 12 into 5 to the power n minus 2 into. Now here if I have to take 5 to the power n outside, so first I have to separate it. 5 to the power n into 5 to the power 1, because again the same reason, when the bases are equal, exponents can be added. They were already added. I have separated them here. Now what will I do first is n plus 1, 5 to the power n plus 1, I will take it as common. 5 to the power 2 minus 16 I will get upon. Now here 5 to the power n, if I take outside, what will I get? 12 minus 2 into 5 to the power 1. Okay. Now here the bases are same, again you can subtract 5 to the power n plus 1 minus n. Okay. Here it is what? 25 minus 16 whole divided by. What will you get here? This n has already gone up, so we don't have to write this. This will be what? 12 minus 10. 5 2s are 10. So here n minus n plus 1 will get cancelled. You will have 5 to the power 1 into 25 minus 16 is 9 upon 2. Hope you are able to see. Okay. If I am not getting the complete space, I might write it to the next, this one. Okay. What is the product of 9 and 5? 45 by 2. But this is an improper fraction. You should never leave the answer in improper fraction. What should you do is, it should be divided. If you divide, what will you get? 22.5 or 22 1 by 2. Now I have written the steps one next to the other because I don't have space here. You should always write one below the other. This is the 11th question. Now we'll go ahead with the 13th question, which is also of the similar type, where we are taking out n common. Now hope you have understood this question completely. If you have any query regarding this, whichever step it is, this is step number 1, 2, 3, 4, 5, out of which if you have any problem, any explanation if you require, you should let me know. I will do the needful. Okay, I think here I will end the session of this one here. I'll take up more questions in the next video right away. Thank you.